Var mı arkadaşlar?
Yok hocam.
Okay. Let's start. From the last semester, you know how it works, right? Computer, that thing is just a machine. That means it only has some wires and metal and plastic, and that's it. Right? Using voltages, electricity, you just put some voltages on wires, which represent some 0 or 1. At the abstraction level, you just abstract this 0 or 1. So using this representation, you just tell the computer what to do, right? The instructions and everything. Also the data itself is represented through those electricity on the wires, whether there is an electricity or voltage on the wire or not, true or false, 0 or 1. Okay, so these are all representatives. You just represent the data and instructions and everything, right? Therefore, we can say that it all starts with the bit. We call it bit. Either it is 0 or 1. The atomic level, the most atomic level in computer science, of course, is the bit. Atom is not, I mean, it is something we cannot divide any further, right? Democritus described it this way, named it this way, some centuries ago. Therefore, we take all these 8 bits together, 1, 0, 1, 1, 0, so it represents what? It makes a byte, right? 1 byte. So this is the atomic level bit, and then 1 byte, and it goes this way. So using these bytes, as you know, we can represent any numbers, any numbers, 0 to 9. Actually, since it is 8 over 2, we can represent that many integers here. If we sign it, I mean negative or positive, it becomes something else, right? 1 to an 8, at most, from 0 to 1 to an 7. And also using that ASCII table, you'll remember ASCII table, we can represent also any symbol, all symbols, positive sign or parentheses or A's, Z's, small letters, capital letters, any type of symbol. Not any, of course, but at most 256 different symbols. It goes this way, right? Data. Well, this is the primitive of data. From the programming perspective, we can say that the primitives, data primitives, are integers, the data types, right? Integers or floats, floating point numbers, or characters, and that's it. And also we can talk about the Boolean type, which is 0 or 1, true or false, right? These are the data primitives, data types. Using these data types, we establish larger data structures. Now it's a different thing. Data type, data primitive, then data structures. What data structures you know up to now? What you know? Well, you know, for instance, in C language it is called array, right? Array. So, array of characters, right? Or we just call it, if it is array of characters, we call it string, right? And also we can view, for instance, some lists instead of array. We use list word to represent the same thing. It can be a list of or array of numbers, right? In C language, array of numbers. But different from C, Python language has some extra capabilities. Which is, for instance, in C language, every element of a list must be in the same data type, right? only integer, all integers, right, in the same list. So if we say, for instance, numbers, for instance, as an array or data list, it should be 3, 5, 95, whatever it goes this way. But in Python, every element maybe or can be a different data type. For instance, this may be a single character, let's say B, while the other one may be some integer or some float, or even a string, okay, or even another list, right? 1, 2, x, y, type of another list, right? So in Python, the elements of lists can be of different types, right? So I just wanted to give you the distinction between the data type and data structure. Okay, this is the data type, the primitive one. It starts with the bit. But at the programming level of programming, from the programming perspective, we can say that these are the basic data types. And using these data types, we create some data structures. Up until now, we've learned a few of them. Actually, there are other data structures with later on we'll cover all of them. Not all of them, of course, but most of them, let's say. But the most important one is the list. And then comes dictionary data type. We learn today also. So, but first, let me show you this picture. What is this? This is the first known algorithm discovered. Okay, it's from 1600 before Christ. So this is an algorithm. What is an algorithm? How we can define an algorithm? What is an algorithm? Can you give me any definition about algorithm? What is an algorithm? Any definition? Ne diyoruz algoritma biz?
Sıralama gibi bir şey mi?
Güzel sıralama ama nasıl bir sıralama? Neyin sıralaması?
Verilerin
Ne?
yapılacak gibi bir şey mi?
Verilerin mi yoksa instruction'ların mı? Ha? Komutların mı yani?
Komutlar.
Değil mi? O verileri işleyecek olan komutların. Dolayısıyla we need to solve some specific problem. First, we need to understand the problem, describe what is the problem, what we're trying to do, what we're trying to solve, what are the expected outputs, etc. After understanding either from bottom to top or top to bottom, we just try to understand the problem itself. Then we need to describe a solution. First, we should decide about the outputs, what outputs we need to produce or develop or whatever from this problem. What is the expected output or outcome in general? And by looking at the data in hand, we should decide about the procedures. What procedures we need to apply to produce that output from these inputs. Okay? So it is called algorithm. It's the way of solving a problem, step by step. Do this, do that. If this is that, then do this. Otherwise, do that. Okay? So it is an algorithm. If you take it in this generic way, you can understand what an algorithm is. So there is nothing to surprise, to get surprised. If you discover some algorithm in 1600 before Christ, it's so normal because it describes to solve some specific problem. I don't know what problem it is, but it just gives us some ways of implementation. I mean, do this, do that, and then at the end, using of course some inputs, whatever it is, using this way, following all these steps, you'll end up with this output or this solution. This is the algorithm. Okay, so this is how we can define or understand what an algorithm is. All right, guys. So, if you combine these two concepts together, which is that data and data types and data structure and algorithm, okay, you can understand the topic or the coverage of this course, all right? So the main thing is, of course, problem solving, and for solving this problem, and whatever the problem is, solving any kind of problem, what data do we have, and through what procedures we then end up try to develop or produce, what output, etc. It's all about this. So since we're using computers for this, we just represent data using some specific ways, which is putting some voltage on the wires, as you know, and we represent them this way, right? So this is just a reminder for you. So if you come to this point, if we talk about the data structures, again, I can say these are the building blocks of software engineering. Here, for instance, the data, the building itself is the system or software, all right? Just like this one, it can be any building, whatever. And to build such a building, we use such building blocks, right? Bricks or whatever, all these slabs, etc. And using them in some certain way, right? According to some plan, we just build buildings. Here, using these data types, we create data structures, and using these data structures, we just, through some certain algorithm, we just develop some software, right? So these are the building blocks of software engineering or programming in general, right? So why it is important for us as future computer programmers? Because otherwise we cannot build a real software, right? Or if you want to develop some software, you need to understand these building blocks. There is no certain formula or something to memorize. In such cases, you need to use this data structure always. There is no way such a way. Okay? You need to decide and discover what data structure you need to create or use. Okay? You also need to create it, because such a thing, for instance, if you're representing some student record or something, you'll create such a structure, right? The student's name and number, telephone number, grades, etc., whatever it is. You just create it, okay? And you just decide about, you just put it in some list structure or some dictionary structure, whatever the structure is, you'll decide about. Just like you'll decide about the algorithm itself. So there is nothing to memorize. Tekrar söylüyorum. Ezberleyerek program çözülmez. Because by definition, a problem is something that you do not know the solution. If you know the solution, it's not called a problem. Okay? If you know the solution, you just apply the solution. There is no problem. But if we are talking about a problem, there is no known solution. You need to create or develop the solution. Okay? So, ezberleyerek bu işler olmaz. Nasıl olur? Analytical thinking. If this is this and this is that, and we need to put them in this way, together, in this way, and create or develop this solution. Okay? You need to develop your or improve your problem solving skills, analytical thinking skills. Okay, let's move on. So, if you understand the data structures, these building blocks, then you can develop, or you will have the opportunity or chance to develop some good programs. Just like this one, if you're gonna use some, let's say, window, you cannot use this one, right? Not brick. I mean, this frame cannot be made of some bricks. Instead, you should use some wooden, whatever it is, okay? Blocks or etc. Just like this one, you'll decide about, for instance, the stock price, or if you're going to keep track of stock price of Apple companies, stocks, okay? What kind of data structure I should build? Okay, let's say that we have some stock price for every day. We can put them in some list structure, for instance. This is a data structure, okay? We created a structure to keep this data and then work on it. For instance, how we can process it? We can compare the stock prices, okay? By looking at this, we can say that, okay, it goes up and again, up and down and again. See? You just process it or try to understand. Later on, next year, we'll talk about data analysis and etc. We'll go in further in data analytics or data analysis. Of course, this is not the only way of representing data. In here, for this course, we're going to use Python language, as I said. In Python, this is the list structure, data structure, which corresponds to C's array structure, you know? Okay. So here, if you are address, you need to give the index of it. Okay. So if you're saying that 0, that means that the very first item in this list. Okay. So it goes this way. But there is another data structure we didn't cover last semester, which is called the dictionary. Okay. Remember, we developed a program as an example in the classroom, in the laboratory, as a dictionary example, right? English-Turkish dictionary. We give some words and corresponding Turkish words, English words and Turkish words, and we expect or ask the user to ask for some, let's say, English word, and we just give him the Turkish correspondence, right? For this English word. If we cannot find it, we say that I couldn't find it. See, remember that example? In Python, there is another data structure which is called dictionary. It is named dictionary. Dictionary data structure works this way. Actually, it is very easy. I provided you 2 different or 3 different Python books, right? You have them. In those books, you'll find the chapter, dictionary chapter, and read it, okay? This is your homework for this lecture, for today. Read that dictionary chapter. There are many different, or a few different examples for this. Buyurun. Buyurun.
Gelmez miyim ya?
Tabii, buyurun.
Boş bir yer bulayım hemen derse gideceğim.
Right.
Hocam burası boş. Ha,
Buyurun.
burası boş.
Siz de benim gibi her şeyi internetten açıp gösteriyorsunuz zaten.
İnternet değil bu ya.
Hı?
İnternet değil bu.
Değil mi?
Okay, so this is your homework for today, okay? Get into these books and find the dictionary chapter, read it, and there are a few examples to work on. It's very easy, actually very easy. It's made up of 2 parts. Every dictionary data structure is made up of 2 parts. One, the first part, is called the key. Okay, there should be a key for the dictionary data type, and there is a corresponding value of that key. Okay, so you just provide the key and say that for this key, this is the value. Okay, so that means that for such an example of keeping track of Apple's stock prices, etc., we can create either this type of list structure, or we can use some dictionary structure. It's the same. Instead of giving, for instance, we could give here the 0, 1, 2, 3, whatever, some index, or instead, we can just provide some dates, like March 4, 5, 6, whatever, and the stock prices, all right? So it's the same. So that means that we can use both structures, data structures, for such a purpose. Then how should I decide about them? I mean, which one to use? Well, you'll decide about it. But you should know that in dictionary data structure, you cannot create a 3rd column or something, okay? But in this structure, there may be many different columns, as I said, and also every item or every element of this list can be in some different data type, different from the C language. It's not allowed in C language, but in Python you can do it. But in dictionary data structure you cannot do this. So why we have such a flexible data structure as list data structure in Python? Why should we use such a dictionary data type, data structure? Why? Well, actually, I'm not going to go into the depth of the explanation, but I can tell you that this data structure is much faster. Much faster than this one. In what means? In the search means or retrieval means, okay? Assume that you have a list structure of, or a list of, let's say, millions of items. If you use list structure, it really takes time. But here in the dictionary data structure, it is much faster. And this is your homework. Do an example of programming using both data structures. One is list and one is dictionary, and compare them, okay? Write a program, ask for, let's say, it can be a stock type of application. For instance, here, there are some commodity names, good names, apple, bread, cheese, whatever, and these are the prices, all right? Let's say that it's a stock system or something. So write a program using this data structure, using lists, and let the user ask you for the price of some certain, let's say apple or whatever, some good, and reach it. Okay, reach it, and take the time. I mean, how long would it take to reach, let's say, in 1,000 of items, okay? But using dictionary data structure, it will take much less. I mean, it will be much faster, okay? Why? We're going to talk about it later on, actually. Not in depth, but I can tell you that it uses a different data manipulation technique, which is called hashing, just like this one. Here, we reach every item one by one, okay? But here, as you see, using hashing, we use some hash tables, etc. That hashing thing is another concept. Not now, but we're going to cover it later on in this lecture, okay? In this course. Hashing, we'll talk about hashing. What is hashing? How we create some hash tables, etc. So, we're going to talk about it later on. So, I'm not going to tell any further about dictionary data structure. I believe that you understood. It has two parts. The first part is the key part and the value part. You just give the key and the value, and if you want to reach some value, you just give the key. It just instantly gives you the value, corresponding value, okay? Try it. Read it and try it. Okay. No additional dictionary or something, library or something is required. That data structure is already in the Python language. So you can use using your Python interpreters, right? Any questions about it? Any questions? As you mentioned, I'm talking about the retrieval efficiency or something like this, right? Actually, we're talking about efficiencies. We'll come back to this item, this topic later on. But let me give you another example before that and work on it. Let me introduce you another topic, which is called approximation. Okay, now we're going to talk about approximation on some examples. Up to that point, any questions, guys? Any questions? Great. Let's move on. Çocuklar, İngilizce soramıyorsanız Türkçe sorun. Anlamadığınız bir şey yok değil mi? Dictionary yapısını öğreneceksiniz. Ödevinizi verdik. Okay. Peki, şimdi size başka bir kavramdan bahsedeceğim ve bu kavramı bir yerlere bağlayacağız. Çok hoşunuza gideceğine eminim. Dediğim gibi approximation konuşacağız. Ne demektir, neden? Peki, şimdilik şunu şöyle bir Şimdi dediğim gibi burada şeylere bakabilirsiniz. Yani biliyorsunuz siz o kitapları verdim ben size. O Python kitaplarını. Oradan siz bulursunuz. Ben ayrıca bulmayayım Dictionary konusunu. Şimdi şu approximation mevzundan bahsedelim. If you cannot get the exact answer for some specific problem, you try to approximate it. What is approximation? Ne demek Türkçe anlamı? Yaklaşık olarak hani bulmak falan, approximate etmek. Okay. Okay. So let's give such an example. Assume that we have a number n, and we want to decide about in which root of that n is. So dolayısıyla burada bir şey var. Elimizde bir y değeri var. Şöyle bir şey. Bu n neyin kaçıncı kuvvetidir? Yani kaçıncı köküdür? Bunu bulmaya çalışıyoruz. Okay. Ve elimizde de böyle bir direkt formül, fonksiyon bir şey yok. Okay. Hani şöyle bir şey. 2 neyin ikinci köküdür diye sorsam, 2 neyin ikinci köküdür? Yani kare köküdür. Neyin? 4'ü değil mi? Dolayısıyla 4'ü bulmaya çalışıyoruz. Ya da işte evet. Ya da onun bilmem kaçıncı kökü nedir filan. Bunu bulmaya çalışıyoruz. Yani neyi bu ne anlama gelir? Şu anlama gelir. N'i yani şu n'i x'inci kuvvetini alırsam y'yi elde ederim demektir. Değil mi? Dolayısıyla ben diyorum ki neyin yani n'i bulmaya çalışıyorum.
Tam tersi değil mi?
Ters söylüyorum yani. Y neyin n'inci köküdür demiş oluyorum. Tamam mı? Yani neyin x'inci köküdür pardon. Yani n'i bulmaya çalışıyorum. Okay. Oldu. Anladık. Okay, let's create some approaches for this problem. I mean, how can I solve it? How can I write a program to solve it? First, we need to decide about the domain, the problem domain. Here, if we assume that this is positive, it should be somewhere starting from 0 to what? To n, right? It can never be greater than n, right? So it should be somewhere in between, from 0 to n. It should be somewhere in between. So actually it describes our problem domain. This is the domain. Since this is a numerical example, we can easily understand what a domain is. But when we say domain, it's a more generic concept. All right? Yani bir problem domaini deyince konuştuğunuz konunun özelliğine göre işte ne bileyim siyasal bir konu bilmem onun problem domaini ne bileyim işte seçimlerin bilmem nesi diyorsanız mesela seçim tahmini buradaki domainimiz bizim aslında Türkiye'dir. Türkiye'deki seçmen nüfusudur falan. Tamam mı? Bu nüfus içinde bakıyoruz bu probleme demektir. Yani problemi ele aldığımız ne diyelim sınırlar, çerçeve anlamında domain. Okay? Problem domaini deyince. This is a numerical example, so it's easier to understand. It's somewhere between. So I will need to search for this solution in this domain from 0 to n. So this is my lower limit and this is my upper limit. Okay? So it should be somewhere. Therefore, let's try such an approach. Assume that I assume this is our answer. I will assume answer. I will assume that the answer is n. So I'll apply this rule. I mean, I'll compute this and compare it with y value. Okay. If it equals to y value, then that means that I got the answer, right? Okay. So this is my comparison and how to decide. This is my approach. This is my algorithm actually.
Bir şey sorayım.
Buyurun.
Şu n üzeri x eşittir y dediniz ya.
Hı hı.
Orada x y'nin üstünde olması gerekmiyor mu? Yani şey olarak siz çünkü az önceki kareköklü işlemde de n'yi içerideydi ya karekökün.
Evet, neyin
Üst, o yüzden y'nin üstünde olması gerekmiyor mu?
Yok. Yani x'in bu kuvvetini alınca bunu elde edeceksin işte. Ha, şöyle olmuş olur değil mi? Yani şöyle olur. X olur.
Evet.
Evet, ne? Doğru söylüyorsun. Yani ilk yazdığımı ters yazmıştım. Değil mi? Okay, so this is one approach. I'll give an answer, give it a shot, give it a try, and assume that this is the answer, the upper limit, and compute this and compare it with y. If it is equal to y, then I'll decide that it is okay. This is my answer, all right? This is my algorithm in general. But if it is not so, if it is smaller than that, I'll decrease it at some certain amount. Let's say step. I'll take a step and decrease the value and try it again. Okay, I'll decrease the answer and do the same calculation and compare it again and decide again and again. It goes this way, right? Until we reach that value, okay? Y. If it is equal to y. But there is another thing. Let's assume that the true answer is somewhere here. All right, this is the correct answer. By decrementing this step value or answer step by step, one by one, here, this way, I may reach here and then jump over it and continue, right? It is possible, right? It will depend on this step value, So then, I should decide about another thing. I should decide about how close should I get to that answer for answering, assuming that the answer is correct, okay? So that means that let's call it epsilon. So I'll say that if the difference between them, that means that this value, let's assume that it is this answer, let's call it A over x equals to some value, y hat, let's say, and y minus y hat, absolute value, of course, because it may be here or there, okay? If we jump over, it will be negative, right? So that we need to get the absolute value. If this absolute value is smaller than or equal to that epsilon value, all right, epsilon value, I'll decide that this is the correct answer, okay? Got it? So we just try to approximate the answer. We don't hope to exactly find the answer, but instead we'll assume that if we get that close, epsilon, then we'll assume that this is the correct answer. So this is approximation, okay? This is giving an approximate answer. Got it? Understood? Questions? Great. So, guys, this is another thing. First, we decided about the domain, right? The domain. That means the lower and upper limits. In what domain that we're dealing with this problem, right? And then, now here we decided about the acceptance criteria. All right? So this is our acceptance criteria. Okay? Or criteria. Okay? Here now we decided about the epsilon, the acceptance criteria. Now we can apply this solution, the algorithm. Okay? Any questions? Any missing points? Great. Then let's check the Python program for this. Okay, guys. Python program. So here there are a few modules. There are a few modules here. Let me describe them first one by one. Here I get the number using that get num function, which just asks for the integer between some upper limit. Okay, gets the answer and returns. Okay, that's the number, and also here. And then I start computing. Here I describe the epsilon and step value, right? See, the step value should be much smaller than the epsilon. The step value much smaller than the epsilon, because it is too large. It may cause here, I mean, it gets here, and then if it is larger than epsilon, we just jump it over and continue, right? Therefore, step value, that decrement value or increment value, whatever, needs to be small, much smaller than epsilon, right? Or small enough at least, so that we wouldn't jump over. Okay. So here I describe the epsilon value. Here, as you see, epsilon is, what is it? 1%, right? Is it percent? No. 1 over 1,000, right? 1,000. And then epsilon is 1/1200 of it. Okay? This is the step value. So here, after getting the numbers, I just call this find root module, giving the number and the step and etc. So here is our function. See, I at the beginning assume that the answer is n, and I just count the number of trials, how many times to try. Okay. See, I just compute this here, answer this one, right? This is R here, not X, but R in the program, right? This is R. So I compute this and get the difference, absolute value, and compare it with epsilon. If it is within this limit, I just jump it over, right? And give the answer. Otherwise, I just go back and get into this and decrement the answer by step, whatever the step is. Okay? Decrement and decrement, try until I reach this answer. I mean, I get that close. See? I get that close. See that? If I get that close, then I just jump it over and return it, okay? But also I put another check here. If I jumped it over accidentally, that means that I moved beyond 0, then I just return -1, which means that I couldn't find the answer, all right? Right, guys? Got the point? So, and at the end, after getting the answer, I just display the result. Where is it? It is here. It just displays the result. Either it says that this is the answer, the result, root is whatever, and if it is smaller than 0, that the root finally failed, whatever. Okay? And also it displays the number of tries, how many times I tried to find that answer, all right? Got it? Any questions about the program, about the algorithm? Any questions? Great. If everybody understood, then let's give it a try. Okay, give me a number now. 5. Let's make it larger. Up to 100. Şöyle yapayım bir dakika. Bir önce büyüteyim. Büyüteyim. Altta göre. Okay, give me a number now. 50 or 50. Peki 50. Okay. And a root. Kaçıncı kuvvetine bakalım? 1 to 20.
15.
15. Okay. Let's see what happens. Boş mu bırakıyorsun ya?
Bir ikini boş bırakmak sayılır.
Let's try it again. You say 50 and 15, right? Okay. Now it's computing and we're waiting. So this is the number, okay? It says that this is the correct answer. Try it. Compute it. Vardır sizin bilgisayar şeyleriniz, kompütürleriniz, ne derler, kalkülatörleriniz, hesap makineniz. 1.2979 bilmem kaç, çın 15. kuvvetini alacaksın, 50 veriyor. Okay?
1.29
Ayrıntı yazma
79,
gerek yok.
69, 99.
Ama hepsini yazmanıza gerek yok.
15. kuvvet.
15 dediniz ya.
29, 79,
99 bilmem ne.
60,
Yani
99.
aradaki fark
15'lik kuvvet.
epsilondan az yani, değil mi? Bizim
Çarpı
söylediğimiz
15 olmaz
epsilondan yani 0.001'den daha az bir farkla cevabı buldu. Buldu mu? Buldu mu arkadaşlar? Peki
Kopyalalım. Ha, tamam.
kaç denemede buldu bunu? Kaç denemede buldu? Bak burada yazıyor. Kaç deneme yapmış? Kaç yazıyor burada?
24.
24 milyon 351 bilmem kaç denemede bulmuş. Okey? Şimdi soruyorum. That number of tries. It depends on what? Of course it depends on the epsilon value, of course, and also more than that, the step value, right? The smaller the step is, the larger it takes, right? Because it will decrement, it goes this way, right? If we decide about the step value larger, there is a danger of stepping it over, jumping it over, right? But if we take it too close and too small, it takes time. Okay? Let's try another number. Okay, give me a number between 1 to 100. Ladies,
70.
70.
70.
70 and the root is
20.
20.
Evet.
Fail. Jumped over.
Vay.
Başka bir şey deneyelim. Yani step value'yu biraz daha farklı almak gerekiyor.
Neden olmaz?
Çünkü 500'de bir yetmedi. Tamam mı? Daha fazla atladı üzerine. Başka bir rakam deneyelim. Şimdi onunla oynamak istemiyorum. Çünkü karşılaştırma yapacağım. Ne demiştin? 70.
Evet. 19
let's say
olsa.
21.
Ha, okay. 20'ye kadar.
Ne oldu?
20'ye kadar yapacağız.
70
Evet.
yes. 70 and 70. Okay, it took that many
Daha
times, that many trials.
34 milyon.
34 million times it tried and come up with the answer. Okay, this is the solution. But can we find another solution? Another approach. Another approach. Any idea? Is this a good solution or bad solution? We'll decide about it later on. But we need to find another solution. Is there any other solution for this? Peki şöyle diyelim arkadaşlar. Bir kere düşünürseniz bir şeyin kuvvetini arıyoruz falan. Hani 0 ile n arasında olacak dedik, eyvallah. Ama mesela 0 ile n arasında aradığımız şey tam bunun ortası olabilir. Ne zaman olabilir mesela? Ben size söyleyeyim. Sadece karesi olduğu zaman olabilir. O da 4 için olabilir, değil mi? Zaten nasıl gidebiliriz? Yani birinci kuvveti, ikinci kuvvet değil ve birinci kuvvetini sormanın alemi yok. İkinci kuvvet dediğimizde sadece 4'ün ikinci kuvveti tam ortası 2 olabilir değil mi? Onun üzerindeki yani 3, 4, 5. kuvvetleri her zaman ortadan daha bu taraftadır değil mi? Değil mi arkadaşlar? Mantıken. O zaman neden biz buradan başlamak yerine buradan başlayıp azaltmak yerine arttırmayalım? O zaman daha kısa sürede buluruz. Doğru mu? Değil mi arkadaşlar? Okay. So what should we change? Well, actually we'll do the same computation and same comparison, but instead of starting with the n value, the initial answer will be 0, and then we'll keep incrementing it. Not decrementing, but incrementing until we reach that difference, smaller than epsilon value, all right? Got it? Okay, let's try this. So this is my second solution here. Now, no. Here, sorry. The second solution is start with here, okay, divided by 2, and then decrement. Okay, this is the other solution. Okay. Tamam, bu solution'u anlamayan var mı? Okay. Now let's try this.
Bir şey sorabilir miyim?
The rest is the same. Efendim?
Normalde girdiğimiz sayının yarısına mı girmemiz gerekiyor? Yoksa direkt aynı sayıya girebiliyor muyuz?
Aynı sayıyı girebiliriz.
Gerçi ikiye bölüyor.
Okay. Bir dakika şurada çıkalım buradan. Şunu açayım. Sonucu verelim. Şurada kapalı çünkü. Comment it out. Okay. Now it will give the second solution first and second solution. Okay, and it will compare. So I'll give the same numbers. What was it? 70 and 17, right? 70. So let's compare the results. Waiting. This is the first solution, and this is the second solution. Okay. Here, the results are very close, right? But both these results are correct. Why? Because both of them meets the acceptance criteria, right? Both of them meets the acceptance criteria. So then we can assume both of the answers as correct. We can accept them as correct, right? But where we see the difference, what is the difference? Well, it tried that many times, 34 million times, but this one, it took only 16 million something times, right? Almost half of it, less than half of it. So if we compare, it improved the efficiency that many times, right? That means they took half of the time, or half of the number of tries, right? All right. Now I'll go to the third solution. Now I'll start from not here but here, from 0 to that point, okay? And compare it now. And this is my third solution here. That's it, yes. Now this is my third solution. Let's check this third solution. Where is it? It is here, third solution. As you see now, I start with 0, right? And instead of decrementing, I just increment, okay? Starting from 0, incrementing. Again, I do the same comparison, compute and compare it with epsilon. If it satisfies, it gives the answer, etc. Okay? No more changes, just the initial value and the increment instead of decrement. Now check this out. For the same numbers, 70 and 17, and compare the results. 70. Okay.
Uzun sürdü.
Üçünü de saklaya tek tek. Bu iki.
First one, second one, and
Üçüncüsü
third
daha
one.
az çıktı.
See that?
20 katası çıktı.
All results are correct, acceptable, but this is 16 million, but here we tried it only 640 something thousand. Okay, so it improved it that many times. So this is the comparison of this one and that one. 26 kere hızlandı bak şuna göre. Buna göre bakarsanız kaç? 52 defa hızlanmış demektir. Arkadaşlar ya bir şey görmenizi istiyorum bakın. Sadece yaklaşımı değiştiriyoruz. Değil mi? Problem aynı, her şey aynı. Yaklaşımı değiştiriyoruz. Bak ne kadar etkileniyor ya. 26 kat hızlandı. 26 da değil. Buna göre 52 kat hızlandı. Doğru mu? Başka düşünce var mı? Başka bir çözüm var mı aklınızda? Soru aynı soru. Peki siz yanaşmadınız değil mi? Kumar oynamayız biz dediniz. Ne güzel bira içecektim sizden geçen dönem. He? Bir oyun oynayacaktık. Sayı sıkıştırmaca yapacaktık. He? Yanaşmadınız. Yemedi. Burayı ısmarlar. Bir öpücük verir. Neyse nesini oynuyorsak zaten. Yazlıklarda oynamak için güzel bir oyun. Bedavadan öğretiyoruz. Bir biraya almayalım yani. Bedavadan size yazlık oyunu öğretiyoruz. Oynamadınız. Fark etmez. Hep buradan mezun olanlar bana bira borçlu gidiyorlar zaten. Sonunda göndereceğim icra farkını tutacağım.
Boşluk kalmayacak.
Valla. Bak önümüz bahar. İçerim biranızı. Buluruz bir oyun sizde, görürsünüz. Peki, şunu soruyorum. Aslında oradaki yaklaşım buna çok benzemiyor mu? Problem. Değil mi? Bak 0 ile 100 arasında bir sayı tut. Ben de onu bulmaya çalışayım işte. Peki ne yapıyorsun? Bir tahmin yapıyorsun. Ben o tahmine bakıyorum. Yukarı mı gitti, aşağı mı gitti diye o tahmine göre yukarı aşağı kaydırıyorum. Bu limitleri kaydırıyorum. Ha? Değil mi arkadaşlar? Aslında algoritma aynı algoritma. Ya da o algoritmaya bakma problemi de uygulayabiliriz değil mi? Bir kere bunu gördünüz mü? Bakın bir yaklaşımı ben başka problemlere uygulayabiliyorum. Ha, onu göresiniz istiyorum. Onu uygulayalım. Yani şunu yapalım biz. Yine bu difference'a bakalım. Eğer hayırsa limiti kaydıralım. İşte hayırsa high limiti yani. Değil mi? Buraya kaydıralım. O tahmin neyse. Düşük çıktıysa low limit'i kaydıralım. Dolayısıyla gene o arada bu sefer her seferinde ortadan bölerek hep ortadakini tahmin edelim. Yukarı mı gittik, aşağı mı gittik? Hep ortadan bölerek. He? Ortadan böl, tahmine bak, yukarı git, aşağı git. Algoritmayı anladı mı herkes? Ortadan böl, tahmini bul, yani karşılaştır. Sonuç yukarıdaysa aşağı doğru git. Yani o zaman yukarı limiti buraya çekeceksin, değil mi? Yukarı limiti değiştir, öbür türlü aşağı limiti değiştir. Nasıl? Bu algoritmanın adı ne? Bisectional search bu aslında. Bisect search. Tamam mı? Bir algoritma öğrendiniz. Dersimizin konusu bu. Bisectional search. Bak bir algoritma öğrendik. Peki bunu uygularsak yarar sağlar mı? Yani böyle bir problemde yarar sağlama ihtimali var mı? Ya bu taraflarda bir şeyse, yani ya tahmin ettiğimiz sayı bu taraflardaysa, şu taraflardaysa iyi mi olur? Sonuca olumlu mu etkiler, kötü mü etkiler? Ne dersiniz? Söyle. Ne diyorsun? İşe yarar mı, tersine mi sonuç verir? Hı? Sen diyorsun aynı olur. Niye? Niye öyle düşündürüyor sana? Ortadan bölüyor. Bu tarafa da düşebilir. Bu tarafa ne bileyim ben diyorsun değil mi? Yani olasılığa bağlıdır. Dolayısıyla tahmin edeceğin yani sayının ne tarafta olacağına bağlı olarak değişebilir diyorsun. O yüzden yarar da sağlamayabilir. Sağlayabilir de. Değişir diyorsun yani.
Ama bence sağlar.
Niye?
Çünkü hani iki taraftan sıkıştırıyoruz ya, ne tarafta olursa olsun yine de hızlı bir şekilde bulacağız.
Bu da bir fikir.
Sayıya bağlı olabilir.
Bu da sayıya bağlı diyor. Sayı bu taraftaysa. Sen ne diyorsun?
Bence mantıklı, evet, sıkıştırarak gittiğimiz için sürekli ne tarafa daha yakın olduğunu bir şekilde daha hızlı bulabilir.
Daha hızlı olabilir diyorsun. Hızlı mı düşünüyorsun? Hızlı olacağını mı düşünüyorsun? Yani. Sen ne dersin? Bak, ben ne yapıyorum? Okey. Peki. Hızlı olur diyen var mı? 3-4 kişi hızlı diyor. Yavaş olur diyen? Hiç mi yok yavaş olur diye? Bak. Yavaş olur dedi adam herhalde ya. Fark etmez, değişir dedi adam.
Neden
Probabilistik-
yavaş olur ama hocam?
Bak probabilistik bir şeydir diyor adam. Bu tarafta da olabilir, bu tarafta da olur, ona göre diyor. Sayının durumuna bağlı probabilistik olarak. Yani yazı tura atmak gibi. The probability of head and tail is what? Değil mi? 0.5. 50%. So it depends. It depends on the number diyor. Okay, this is our another solution which is called here dissectional solution. Find root using dissectional method. Here, let me describe the method. Here is the algorithm. Here, as you see, the low limit and high limit is between 0 and n, and I take the initial answer as this one, okay? Okay, this is my initial answer. The midpoint, okay? The middle point. And number of trials. Here again, I compute and compare, etc. If it is lower, then I just move the low limit. Otherwise, I just move the high limit. And now, my next trial, next answer, is the midpoint of between these two. Okay, new high and low limits. Okay, great. Everybody understood? Any questions? Okay, let's give it a try. The same numbers, 70 and what was it? 70. Okay. Waiting. I'm waiting. I'm waiting. Waiting. Waiting. Waiting. Waiting. Hadi lan. Buldu lan.
23.
Hop.
Ben de dedim. Ya.
Ne oluyor ya? What the heck is this? What the heck is this? That took 34 million times and 16 million times and 600,000 times and what the heck is this? 23 times. Okay, it's a coincidence, right? Just a coincidence. Let's try it with some other number. Exit, no. Let me, give me another number. Another number. Söyleyin, başka bir sayı söyleyin.
53'e 13.
Okay. 53 and
Değişik olsun
30.
diye
Rize'ye.
Yok hocam olmaz.
Let's see what happens.
Olmaz.
Sizden kimden?
Demek ki
Ne diyorsun?
sayıda çıkacağız yani.
Ha? Ne oluyor ya?
Sayı artacak.
19 times. Another coincidence. Okay, another one. Give me another number.
Hocam 100. 100 versek.
100.
Evet.
Okay. And
20.
Yalan mı? 5 bin. Tüm katlar topladın.
yani 100'ün 20. kökü nedir demiş.
Yapamadım.
Değil mi?
Yapamadı hocam.
Peki yani işte 99'a 10 20 ne diyeyim.
19 olsun. 99 olmuş.
Hayır, şeyde burada var. Bir tanesi.
Onu bulmadım.
Birincisi de bu.
Bulmuş aslında be. Cevap veriyor.
Niye böyle?
Ne oluyor?
İlk ikisini bulamadım.
Ha, diğerlerini bulamadım. Bunu aramaya devam ediyor değil mi?
Sonuncuyu buldu sadece.
Son yöntemle buldu. Aradaki yöntemle üstünden atladığı için bulamamış olabilir. Yani.
Evet.
23'e 45 verir misin?
45 veremem çünkü 20'ye kadar bekliyorum. Yoksa çok
O
bekliyorum.
zaman 13'e 17 olur.
13'e 17. 13 and 17.
Yapmadık ki.
ne kadar hızlandırdı? Şimdi deminki örnek üzerinden karşılaştıralım. Yani no diyelim. Neydi ilk örneğimiz? 70 and 70. Okay. And what was the improvement rate? See, it improved it, accelerated it that many times compared to this one, right? Yani buna göre 27.000 kat artmış, hızlanmış. 27.000 kat. Bu ise 26.000, bu ise bilmem ne. Abi ne oluyor ya? Çarparsan 27 çarpı 26 çarpı 2 demen lazım. Yani ne diyor? 27.000 çarpı 26 çarpı 2 diyeceksiniz. Arkadaşlar ne oluyor ya? 1,5 milyon kat hızlandı değil mi? Any other solutions? Any other solutions? Bunun ötesi medyumluğa girer arkadaşlar, tamam mı? Aslında var. Yani bir solution daha var. Bunun formülü var yani. Bunu formüle koyarım. Şart diye sana hesaplar söyler de. Ama yani bizim approximation'ımızla alakası yok o solution. O bilinen bir şeyin uygulanması. Biz burada approximate etmeye çalışıyoruz. Okay. It is surprising, right? So, learning, lessons to learn. Lessons to learn from this example. What is it? First, we understood what an approximation is, or solving a problem through approximation method. What it is, we learned it. And also, we understood that there may be different solutions for the same problem, right? And of course, all these solutions are supposed to be correct. How we decide about the correctness? Well, it will be described on this acceptance criteria. If the solution meets that acceptance criteria, then we can assume it is correct. So there may be different solutions for the same problem, and we should decide about which one is better. Which one is better? Why? Why? You can say that the last solution is a little bit more complex, etc. Right? But here in computer science or software engineering, we should say that the let's say betterness or whatever should be decided based on the time complexity or the time it takes, right? CPU complexity. How many, I mean, how long it takes to have the CPU run on this, okay? CPU time. So we'll decide about it based on the CPU time. Time efficiency, we call it. Later on, we're gonna come back to that point and I'll describe you how to compute the time efficiency and memory efficiency also next week in the same lesson. Okay. Any questions? What we learned, there are different types of data structures and we should decide about what data structure to use depending on the problem. And also we can come up with different solutions, different algorithms as you see. And some of the algorithms can be much better, much better than the other one. Based on what? Based on the time complexity. Or in some cases, memory complexity. We'll talk about it later in the next week's lecture. Any questions? Okay. That's all for us.